This is what we call a total and tonal reflection microscopy setup. Here you can see that there's a red light on that is incident on a right-angled prism, where the light is totally internally reflected at the top surface of the prism, where there's a glass slide resting on top, optically coupled by a oil that has the same density as glass, about 1.5, and the light is then reflected and transmitted into the camera. And so this is really the basic setup, and you can also see that there's a box in between the light and the prism, which is a polarizer, and this basically gives us a known reflective behavior and transmitted behavior of the light when it's polarized. Therefore, thus we can use the Fresnel laws in optics to basically have a good understanding of the reflected and transmitted components of the light on top of this prism. And so on top of this prism, let's say that we put a glass with a known radius of curvature, then we can get the exact profile of this glass, knowing that on the top surface of this glass, when light is reflected, it creates what we call a evanescence wave that decays exponentially from the top surface. And basically this glass with a known radius of curvature will basically frustrate the evanescence wave with a nanometers away from contact up until about the wavelength of the light. So the wavelength of the light right now, this is red light, and so it's about 660 nanometers. And so we can image anything really under 660 nanometers based on this frustrated internal reflection. And Fresnel's laws basically tells us that because this is polarized light, that for the light that is frustrated, there's actually some reflected components at the bottom surface of the glass, and thus we can use that correlation to get the exact profile of the glass and compare this, for instance, with the exact curvature of the lens given to us from the manufacturer, as well as something like a reflection interference microscopy to cross-check our results. And we get a very good agreement in our results when we do this. And so this is just a overview of the optics that are involved to set up this TIRM setup.